Hey guys, so today we're going to talk about periodic trends. Periodicity is one of the most fundamental aspects of the periodic table. It refers to the recurrent trends in elemental properties. In order to discuss the periodic table, we need to go back to 1869 when Dmitri Mendeleev created the first periodic table. He had written the properties of elements on pieces of card and arranged them in order of increasing atomic weight. He found certain trends in his periodic table, known as periodicity. The modern periodic table is very similar to Mendeleev's, but elements now are organized by atomic number or number of protons rather than atomic weight.
The periodic table is organized according to periods and groups, which are the rows and columns. The groups are referred to as families. There are the alkali metals, the alkaline earth metals, the transition metals, the halogens, and the noble gases. All of the elements in each group have the same number of valence electrons, making them have very similar chemical properties. As we move across a period, the number of protons, neutrons, and electrons increases. As we move down a group, the number of electron shells increase.
The periodic properties we're going to look at include ionization energy, atomic radius, electronegativity, and electron affinity.
First, we have ionization energy. Ionization energy is the energy required to remove one electron from the outer shell of an ion or gaseous atom. As you move across a period, the number of protons increases, creating a stronger attraction between the nucleus and the electrons. This positive charge experienced by the electron is called the effective nuclear charge and is often written as Zeph. The increasing Zeph makes it harder for the electrons to be removed from the atom, causing the ionization energy to increase across the period. As you move down a group, the number of electron shells increases, so the valence electrons are farther from the nucleus. This causes their attraction to decrease, in turn decreasing the ionization energy.
Next is atomic radius. Atomic radius is half the distance between the centers of two atoms. Put simply, atomic radius is the size of the atom. The trend for atomic radius is, when you go down a group, atomic radius increases, and across a period, atomic radius decreases. When you go down a group, the number of energy levels increases as the number of electrons increases. Each subsequent energy level is further from the nucleus than the last. When you go across a row or period, atomic radius decreases because of Zeph. The pull of protons is greater than the pull of electrons because the difference between the mass of protons and the mass of electrons increases. Since the number of protons increases across the row, the Zeph is greater and the atomic radius decreases. Think about it this way. You have a pile of Skittles and each Skittle represents an electron. The more Skittles you add, the bigger the pile gets. This is the same for atomic radius. Ionic radius follows the same trend as atomic radius but applies to ions instead of neutral atoms.
Now we're going to talk about electronegativity. Electronegativity is the measure of the ability of an atom to attract electrons and form a chemical bond. As we previously said, going across a group causes the atomic radius to decrease. The smaller size allows the protons in the nucleus to exert a stronger pull on nearby electrons, increasing the electronegativity. As we go down a group, then the atom gets bigger, the nuclear attraction decreases, as the electrons are farther away from the nucleus. This causes the electronegativity to decrease.
Finally, let's discuss electron affinity. It is defined as the likelihood of gaining an electron. Electron affinity increases from left to right across periods and generally decreases down groups. This is because the less valence electrons an atom has, the least likely it will gain electrons. It'd rather give away an electron to become stable, not receive another electron. It decreases down a group because as you go down a group, the electrons are placed in a higher energy level far away from the nucleus, thus resulting in a decrease from its pull.
To sum it up, the periodic trends depend on where the elements are in the modern periodic table. As we go across a period, the ionization energy, electronegativity, and electron affinity increases. The atomic and ionic radius decreases. As we go down a group, the ionization energy, electronegativity, and electron affinity decreases. The atomic and ionic radius increases. Thanks for watching our video, and we hope to help you understand periodicity better.